So let's get started answering the concept questions. First, how are the zones of the ocean divided? First off, we can divide them into different ocean zones. There are 5 major ocean basins: Pacific, Atlantic, Indian, Southern, and Arctic ocean basins. But water flows freely among all of the basins, creating one giant ocean. There are also world climate zones. Latitudinal regions are divided into climate zones, which you might be very familiar with. These vary in physical factors such as sunlight, rain, and temperature, all of which help to shape marine environments. Outside of the equator, there are the tropical regions, and then there's also the temperate regions and the polar regions. These climate zones also divide terrestrial environments within those regions. But the division of the marine environment can be further subdivided into zones based on distance from shore, light availability, and depth. So let's check that out. So these are terms in which we use to contrast each other. The ocean division zones, such as the intertidal, or the range between the high and the low zone, and the subtidal. That would be the entirety of the sea below the low tide. There's the Nearctic, which is near shore, and the Oceanic, which is seaward or offshore. There is the pelagic zone, which includes all of the water column, and the benthic zone, which includes the seafloor. There's the photic zone also, and that's the depth that sunlight penetrates. And can you look on the diagram and maybe see what contrasts the photic zone? Just a second. The aphotic zone. So this is where sunlight does not penetrate beyond that zone. So further, you can see how the oceans are divided by depth. The epipelagic is the upper 200 meters, and this includes the entire photic zone, which is how we say. The mesopelagic goes to about 1,000 meters down, and this is the dysphotic or the twilight zone. Beyond that, you'll have the bathopelagic zone, which is the zone known as the aphotic zone or no light zone. So all zones, including this and beyond, deeper down, are going to be the aphotic zones collectively. The abyssal is the deepest zone in most of the world's oceans. So the average depth of most of the world's ocean. In some places, it gets even deeper though, and you'll have the hadal zone, which is beyond 6,000 meters. This includes the deep ocean trenches, such as the Mariana Trench, which is 11,000 meters deep. So moving along and summarizing, how are the zones of the ocean divided? There are 4 divisions, which we've talked about: the world ocean zones, the world climate zones, the ocean division zones, and the ocean depth zones. So now we're going to answer the second concept question. What types of environmental factors might be different in different oceanic zones? So environmental factors vary widely across these zones. You can see that abiotic factors such as the amount of sunlight, pressure, temperature, biomass, diversity, and abundance all change with depth. So which 3 can you see on the graph to the left? I'll let you go ahead and take a moment. Right, so the 3 that you can see are biomass, light, and temperature. So we can see that biomass is very abundant in the epipelagic zone, and it tapers off once you start getting to the mesopelagic zone. Or so we know for now. There is quite a bit more to explore. Light also starts tapering off, as we know, in the twilight zone and the mesopelagic zone, and temperature as well. So as you can see, temperature starts off pretty high, about 20 or so degrees Celsius, and then there's that thermocline, or that sharp decrease in temperature down through the epipelagic to the mesopelagic zone. Once you start getting where there is no light, the temperature stays pretty standard. And so because of the high variability in combinations with all of these environmental factors, marine organisms have evolved immense diversity and life strategies to take advantage of all available marine habitats. So who are these marine organisms? And who lives in the different zones? So some of these terms might be new to you, but we'll go through them. Pelagic organisms include the plankton, the neuston, and the nekton. Now, plankton are the organisms that live suspended in the water column. They might have some locomotory power, but not enough to overcome major ocean currents or turbulence. Where the neuston are organisms associated with the sea surface, including microbes with the surface slick of the sea. Now there's also something else called the pleuston, and those are organisms that live in the thin layer existing at the air and water interface. They protrude out of the water as well, such as man of war. So think of protruding neuston, kind of, pleuston. There are also the nekton organisms, which are larger animals that swim in the water column. Can you think of any? Most of the organisms we know, such as fish, shark, sea turtles, those kind of things. Now the benthic organisms, or benthos, is what's collectively known as the animals and plants that are associated with the seafloor. These include infaunal or semi-infaunal, which on the diagram you can see that these are the organisms that are slightly buried beneath the sediment or the sand. These include clams and other organisms. Boring organisms, you can see on the left, are the organisms that bore into hard surfaces such as rock or wood or even shells of other organisms. The epifaunal organisms are things such as crabs or sea urchins that live on the surface, or the epifaunal. Demersal also are the bottom fish, such things as sole or halibut that swim along and live near the bottom of the ocean floor. So this is a great resource for you. Who really lives in the different ocean zones? You can click on the web link to the right of the page to find out. You can see all the way down to the ocean and see the different types of organisms that live there. So what types of environmental factors might be in the different oceanic zones? We've named a bunch, but they do include sunlight, pressure, temperature, biomass, abundance, diversity, and many more factors that we're going to explore in the future unit.